Good evening, everyone. My name is Junaid Hussain. Me and my team will present our project Automobile Sales Data Analysis and Forecasting. I'm starting with abstract. Our project address a critical challenge in the automotive industry, transforming raw used car data into actionable intelligence. We have developed a comprehensive framework that processes overall 50,000 vehicle listing through systematic cleaning exploratory analysis and structured classification by creating balanced price and mileage categories and implementing a machine learning pipeline. We have built a scalable solution for market segmentation that supports dealer, consumer, and financial institutions in making data driven decisions. The used car market is expanding rapidly, with online platforms generating massive amounts of data. Traditional valuation methods struggle with this scale and complexity. Our work bridges this gap by applying systematic data science approach to automobile sales data. For this thing, we established some objectives. Let me go through it. Number one, clean and standardize a large automobile dataset. Perform comprehensive exclamatory analysis. Number 3, create balanced classification targets. Number 4, structure a reusable machine learning pipeline. Now I am going to describe dataset description. Our dataset contains overall 50,000 real world vehicle listing with 7 key attributes: manufacturer, model, engine size, fuel type, manufacturing year, mileage, and price. The data spans vehicle from 1984 to 2022 with price ranging from just $76 to over 1,68,000, representing the full spectrum of the used car market. Now we have data clean process. We implemented data cleaning, standardizing all column names, identifying and reviewing 12 duplicate records, and verifying there were zero missing values. This gave us a clean datasheet of 49,988 unique vehicles, a solid foundation for analysis. Now, let me hand it over to my friend Ifat, who will explain our analytic approach.
Hello everyone, I am Ifadislam Arya and I'll be talking about the exploratory data analysis and the methodology that we used for our project. We began our analysis by examining the dataset's structure, statistical properties, and distributions. The dataset contains key features such as selling price, mileage, kilometers driven, year of manufacture, fuel type, seller type, transmission, and ownership type. Understanding these variables is critical because they directly influence the value and performance of vehicles. For the idea, we explored the distribution of selling price across the dataset. The histogram of prices revealed the most vehicles are clusters in the low and medium price ranges, while very few cars fall in the high price category. Similarly, analyzing the mileage distribution showed the most cars have moderate efficiency with fewer vehicles at the extremes of low or high mileage. To better analyze relationships, we categorized continuous variables into three classes: low, medium, and high for both price and mileage. This transformation allowed us to perform classification tasks later. Bar charts depicting the distribution of price and mileage are classes were created, clearly showing the relative frequency of each class. Now on the methodology and model designs. We focused on creating solid pipeline for predicting car price and mileage classes using machine learning. First, we pre-process the dataset categorical behavior variables like fuel type, seller type, transmission, and ownership were encoded using one hot encoding, while numerical variables such as selling price, mileage, and kilometers driven were standardized using standard scalar. This pre-processing ensure the features are on comparable scales, which improves the performance and stability of our models. Next, we define the classification task. The primary objectives were predicting for both price and mileage class of a car, low, medium, or high. We designed a decision tree classifier for both tasks. The decision tree model was chosen due to its interpretability, ability to handle both numerical and categorical data, and strong performance on relatively small datasets. A max depth of 5 was used to prevent overfitting, and minimum sample threshold were applied to ensure statistical robustness. For price and mileage classification, the preprocessed features were split into training and testing sets using an 80 to 20 split. After training, the model's performance was evaluated using accuracy, precision, recall, and F1 score. A confusion matrix was generated showing how well the model predicted each price class. Cross-validation confirmed the stability of the model across multiple folds, ensuring the predictions were reliable. To sum up, the EDA provided a clear understanding of the dataset, guiding our methodology and preprocessing choice to capture patterns in data with help of decision tree classifiers for both price and mileage. That's it on my part. Thank you for listening. Now, next part tells Sushi.
Thank you. I'm Farzanakta Shoshi. I will now present our comparative finding and conclusion from this comprehensive analysis. Comparative model performance. After training our decision tree models for both price and mileage classification, we conducted a detailed comparative analysis. The price classification model achieved approximately 85% accuracy, while the mileage classification model reached around 82% accuracy. Through five-fold cross-validation, we found the price model demonstrated greater stability with lower variance across folds, indicating stronger robustness. Examining the confusion matrices revealed insightful patterns. For price classification, most misclassification occurred between adjacent classes, low to medium or medium to high. Similarly, for mileage classification, error primarily happened between medium and high mileage categories. This makes perfect sense. Vehicle naturally transaction between neighboring categories rather than jumping across extremes. Now, let me address a key classification about accuracy claims. When we earlier mentioned 100% correct classification, we were specifically referring to the labeling precision. During our data presentation phase, we using uh, quantile-based discretization, we mathematically ensures perfect class balance. Each category contains exactly one third of vehicles. This is about perfect labeling, not perfect prediction. Our actual predictive accuracy is what I just shared, 85% for price and 82% for mileage, which are excellent result for real world classification tasks. Future insights and relationship. Our feature importance analysis revealed crucial insights for price classification. Variable like mileage, manufacturing year, and engine size were most influential with categorical features like fuel type playing supportive roles. For mileage classification, numerical indicators dominated, uh, particularly vehicles' age and usage patterns. We importantly, our analysis, most importantly, our analysis confirmed the strong negative corrections between price and mileage that we hypothesized. Higher mileage consistently associates with lower price categories, while low mileage vehicles command premium prices. However, and this is key, it's not a simple one to one relationship. Luxury vehicles with moderate mileage might still be high priced, while an economic car with low mileage remains affordable. Our decision tree models captured this Norrin relationship effectively. Practical applications and conclusions. So, what does this mean in practice? For automobile dealers, our model provides data-driven pricing framework that reduce subjective judgment. For consumers, they offer transparency in understanding vehicle valuation. For market analysis, they reveal patterns in depre- uh, depreciation and consumer preference. In conclusion, our study demonstrates that machine learning effectively captures complex automotive market relationships. Price classification shows slightly better predictability than mileage classification. Decision tree provides interpretable, actionable insights for stakeholders. And lastly, feature engineering and balanced class creation are critical for model success. We have developed not just academic models, but practical tools that can be deployed in real world automotive marketplace. Our framework is scalable, interpretable, and ready to support data driven decision making across the industry. Thanks for hearing us with lot of patience.